Yeah, am I audible, ma? Am I audible? So this class is for basic electrical engineering of HPCL syllabus for mechanical engineers. The syllabus is that fellow mentioned the syllabus. Syllabus looks quite big, okay, frankly to speak, but the contents are very easy. Only basic contents they will ask. They are not going to dig in depth. Basically, the HPCL examination itself is a very easy examination. In that, for mechanical guys, some portion of electrical is added. One YouTube session, live session, I already taken. The same you can find on YouTube, and its a PDF is also available for you, right? If you want the PDF, you can contact us. Okay, okay. So here, this is second lecture. In the first lecture, I discussed about Ohm's law, yes, and after that I discussed about KVL, KCL, okay, nodal, mesh, and some problems, and power, when it is able to supply the power, when it is able to absorb the power. These things I discussed in the first session. So in this session, I'm going to discuss. In fact, that fellow mentioned Kirchhoff's laws, Ohm's law, theorems also mentioned. So there are some theorems like superposition theorem, Norton's theorem, Thevenin's theorem, and maximum power transfer theorem, reciprocity theorem. These theorem statements we are going to see, and some simple problems, and some simple problems I'm going to take up. If yes, Rahul, yeah, hi Rahul. So if any questions you have, you can type in the chat box. Okay, I'll be answering your queries. Any questions if you have in the, if you have, you can type in the chat box. So I hope all of you watched my first video, which I taken on YouTube. Okay, that is belongs to the same. There I covered KVL, KCL, and Ohm's law. Okay, just for recap, let me take up, that is, what is Ohm's law? What is Ohm's law? In your syllabus, it is mentioned, please. That fellow, HPCL fellow, clearly mentioned Ohm's law, DC circuits, KVL, KCL, and after that theorems. Yeah, you can find. I'm able to see. If you want, I'll read the syllabus also once. If you want, I'll read the syllabus also once. So I recap the last class things just for 5 minutes, not more than that. And after that, I'll go with in today's class some two things called voltage division and current division. I hope in the last class I discussed about series combination, parallel combination of resistances. These things I discussed. Yes, to the best of my knowledge, I remember. If not discussed, you can ask me now. I'll discuss the same if something is missing. So some questions. Instrumentation engineering का video बनाया है sir. Okay, yeah, we'll note that point, Mr. Naresh. We'll note that point. Okay, don't worry. Yeah, come here. Let me tell you the syllabus. The syllabus that fellow clearly mentioned. Here it is. Just a minute, ma. Yeah, basic electrical engineering, DC circuits, ohms, and Kirchhoff's laws, mesh and nodal analysis. Yes, in the last class I discussed about the mesh and nodal analysis. Okay, mesh and nodal analysis, circuit theorems. So up to that, the first line of syllabus I'm going to complete today. Up to first line of syllabus I'm going to complete today. Okay, see, simply, what is Ohm's law? What is Ohm's law? Last class I discussed, but still I'm taking the same. Ohm's law. What Ohm's law says is current through any conductor is directly proportional to voltage, and it is inversely proportional to current. Sorry, resistance. Inversely proportional to resistance. I is equal to simply V by R. The units of I are amperes. The units of V are volts. Okay, and the units of resistance are ohms. That is a symbol of ohm. Okay, as you are from mechanical background, I'm taking very simple way, and this simple questions only will be asked. The reciprocal of resistance, R is the resistance. If I take its reciprocal, we're going to get something called as G, which is nothing but conductance. What is G? G is what? Conductance, and its units are mho. Right? That is Ohm's law. See, if I is equal to V by R, simply from that you can write V is equal to I into R. From that we can write R is equal to V by I. Means Three things are there. In those three things, one will be unknown, remaining two will be known. You have to find the third one which is unknown for us. Yes. Some questions in the chat box. So Sunil, today onwards will continue regular. It will continue in how many days this subject is completed? Okay, let us see. Rahul, we will definitely notify you. Okay, Sunil. So Sunil will. Rahul is asking, sir, I am presently in fourth year. Sir, take my doubt too. So you are in final year. Okay. In the notification, is it not mentioned that final year guys are eligible, or the BTech degree is required? I don't think final year guys are eligible. Okay, please check it out in the notification. That's all. See, this class session is for technical, not to discuss about non-technical. If you want to discuss any non-technical things, no. See, please take my number. See, take my number, and you can message me. This is my number. You can message me or call me. Okay, but we don't want to waste our valuable time in discussing non-technical questions in the class. Only technical we will be discussing, right? Yeah. What is KVL? What is KVL? Kirchhoff's voltage law. Let me write those things. KVL, I discussed already. KVL. Yeah. What is KVL? KVL is Kirchhoff's voltage law. KVL is Kirchhoff's voltage law. What this is saying? Kirchhoff's voltage law says that sum of all the voltages in a closed path must be equal to 0. Yes, sum of all the voltages, voltages in a closed path, must be equal to 0. Sum of all the voltages in a closed path must be equal to 0 is given by KVL, Kirchhoff's voltage law, right? So if I take one simple example, and from where this KVL is derived, so KVL is derived from, what is the basis for KVL is derived from law of conservation of energy, derived from law of conservation of energy. KVL is derived from law of conservation of energy. Okay, now let's take one simple circuit, or that is a resistance. This is a voltage source, DC voltage source, plus minus. This is, suppose I'm taking 10 volts. Okay, resistances in series will be directly added. You know this. So these things I already discussed in the last class. That's why I'm not going much in depth. See, this is suppose 5 ohms. This is in 5 ohms. You know, current entering terminal is taken as positive. I told you. Yes, current entering terminal is taken as positive. Now this is source. Battery is the source. Battery is the one which is going to drive the current into the circuit. Battery is the one which is going to drive current into the circuit. Therefore, current of I will flow this direction. Sir, how do you know in this direction? Yeah, plus, from plus terminal onwards, current will leave in this circuit. Now how to find current? Current I is equal to, according to Ohm's law, I is equal to voltage V. How much it is? 10 divided by resistance R. But two resistance are in here. Two resistance, both are in series. If resistances are in series, both will be added. Therefore, how much it is? 5 plus 5, it is 10. It is 1 ampere. So 1 ampere of current is flowing. That as current is entering, this is plus, this is minus, this is plus, this is minus. Current entering terminal is taken as positive. Now, what is the voltage here across the resistance? According to Ohm's law, V1, let's call this one as V1. V1 is equal to I into R1. So how much is V1? I is 1 ampere, R1 is 5. Therefore, that is 5 volts. The same way, V2 is equal to I into R2. That is V2 is equal to I is 1. R2 is 5, therefore it is a 5 volt. So this is 5 volt, this is also 5 volt, right? Now I'm writing it's KVL. What KVL says, sum of all the voltage in a closed path must be equal to 0. See, with this I'm making you to habituate for the sign convention, like where to take plus, where to take minus, what is the direction of current, simple things. See, simple question will be given, but there you must not be in a position to do any mistake. Okay, you should not commit any mistake. So Sunil asked some question. From today onwards classes will continue regularly. It will continue how many days? Subject is completed. Yeah, for sure we'll complete the subject. So how regularly we are going to keep, definitely that will be notified to you on YouTube, man. Okay, see, I'm writing KVL. Observe here, I'm writing KVL, very simple, right? See, you can start anywhere. I'm starting here, therefore what is that? Minus 10, go forward. So KVL is means it is a closed path. KVL must be written in a closed path where you have to, where you started, again you have to end there only. I started at this minus here, minus 10. If I go forward, plus 5. If I go forward, plus 5. And if I, this point, both are same, I am here, that is equal to 0. So from this one, 0 is equal to 0. KVL is satisfied. Okay, KVL is satisfied. So that way we have to write the KVL. What is KCL? Kirchhoff's current law. Okay, KCL. What KCL says is sum of the currents entering a node, entering a node must be equal to, yes, must be equal to the sum of the currents leaving, sum of the currents leaving that node, right? Sum of the currents leaving that node. Clear? Sum of the currents leaving that node. So this KCL is from, and it is derived from law of conservation of charge. Derived from law of, yes, conservation of charge. It is derived from law of conservation of charge. Let me take one simple example. That is this one. See, I'm giving one question. This is a node. What is a node? Node is a point at which more than one branch meet. Node is a point at which more than one branch meets. Suppose I'm giving, for example, this way. See, this is 2 amperes. This is 4 amperes. This is minus 6 amperes. And this is X. X is equal to dash amperes. Please, all of you, tell me the answer, please. Tell me the answer. Yeah. I'm expecting answer from you guys for this question. See, sum of all the currents at a node is equal to 0. That is given by KCL, Kirchhoff's current law. Tell me. Yes, I'm waiting for your answer. What is the value of X in amperes? Yes, Rahul, Sunil. Yeah, all guys. Try it. I'm waiting for your answer. Yes, I'm giving you 1 minute of time. Within 1 minute, if you are not in a position to give the answer, then I do. Yes. Answer, please. Simply, that is very simple, as I told you. Sum of all the currents entering must be is equal to sum of all the currents leaving. I repeat, sum of all the currents entering is equal to sum of all the currents leaving. Sunil given answer as 0. Okay, 0. Let us see. Sunil given answer already. Anyone? Yes. Come on. Anyone other than Sunil? Okay. Vijay, Tech Vijay is also giving 0. See, let us see whether it is correct or not. This is a node or a junction. 2 is coming. 4 is also coming. In fact, minus 6 is also coming. Plus of minus 6. That is equal to only one is leaving. Therefore, 6 minus 6 is equal to X. X is equal to 0. Very good. Sunil and Vijay. X is equal to 0 amperes. That's all. See, there should not be any circuit which violates KVL and KCL. If you take any circuit, KVL and KCL must satisfy. These things we discussed in the last class, because these are required for me to understand further. The next one is simple. I'm taking voltage division. I'm taking voltage division rule. Voltage division rule. What is this voltage division rule? Suppose if I have two resistances like this, if I have two resistances like this is V, this is R1, this is R2. Now in this one, current of I is flowing, same as that of previous circuit only. If this voltage is V1, this voltage is V2. What is V1? According to voltage division rule, V1 is equal to total voltage V into the resistance across which you want the voltage by total resistance. Yes, same. V2 is equal to total voltage into the resistance across which you want the voltage by total resistance. Right? That is voltage division. Means this voltage division tells us how the voltage is getting divided between two elements. Right? The next one I'm taking up is current division. It is somewhat opposite to voltage division. Current division. So this will tell us how current is going to divide. So I'm taking a current source. This is a symbol of current source. I'm taking two resistances like this, two resistances like this. So this is R1, this is R2, this is current I. I'm assuming this current as I1, this current as I2. Simply tell me what is I1. Current I1 is equal to total current I into, previously in voltage division what we taken that resistance, but here we have to leave that resistance, we have to take its opposite resistance. Means when you're finding I1, R2 by R1 plus R2. When you're finding I2, that is I into, sorry, this is I into R1 by R1 plus R2. Means here I'm underlining these things. If you see, if I want to 2, I have to take resistance 1. If I want 1, I have to take resistance 2. Right? Resistance 2. That is what? Current division. Current division. So one simple example, let me take one simple example, that is here I'm taking like this. This is 10 amperes. Yes. This is 10 ohms. This is 5 ohms. Now the question is like this. Suppose I is equal to dash. I is equal to dash amperes. I'm waiting for your answer. Yes. 1 minute is the time given for you to solve this question. Yes. Sunil, Vijay, Naresh, Rahul. Yes, please solve this and give me the answer, please. Solve this and give me the answer, please. All of you. Try it, please. Try it. Very easy question, dead easy question. And this class is not for electrical guys. Okay, please do remember, electrical guys don't think that sir is teaching very simple things. This class is exclusively for mechanical guys who are going to appear for HPCL examination. Okay, answer please. So without pen paper also you can do the same. Without pen paper you can do that question. Okay, yes. Current I, please. How much it is? Come on. I want I is equal to total current, it's 10. In which you want current, leave that, take its opposite resistance, 5 by total resistance 5 plus 10. So I is equal to, yes, 10 into 5 by 15, 5 threes it is. So I is equal to, am I correct? Yes, it is 10 by 3. 10 by 3 amperes. Let's take it as I2, for example. Let's find I1 also. I1. What is I1? So I1 is equal to 10 into 10 by 15. How much it is? 5 twos, 5 threes. It is 20 by 3. And here KCL is satisfied or not? Let's see. KCL is satisfied or not? KCL always should satisfy. Yes, Siddharth given correct answer. Sudarshan given correct answer. Very good. This is the total current I that must be equal to, I is equal to I1 plus I2 KCL. What is I? Let's find 10 it is. I1 how much we got? I1 we got it as 20 by 3. I2 how much we got? 10 by 3. So 10 is equal to 20 plus 10, 30 by 3. So 10 is equal to 10. You see, KCL is satisfied, right? So this way you can verify whether your answer is correct or not. Tilak Raj, fine, good. Yeah, now that is about KVL, KCL, Ohm's law. KVL, KCL, Ohm's law. Let us see nodal analysis. What does it mean by nodal analysis? Nodal analysis means KCL plus Ohm's law. What is that? KCL plus Ohm's law is nothing but nodal analysis. Please do remember this statement. KCL plus Ohm's law is nodal analysis. I'm taking one simple question. Observe here carefully, please, all of you. Yeah. Now, what I'm doing is here, this way I'm taking one question. Yeah, this is the reference or 0 volts or ground, whatever it is, 0 volts. See, in any given circuit, you take the downside one as reference node. In the last class, I told you how to find the number of nodes, number of loops, number of meshes, these things. Yeah. Now, suppose I'm giving these values as this one I'm giving it as 10 volt, this one as 2 ohm, this one as 2 ohm, this one as 2 ohm, this one as 5 amperes I'm giving. Okay. Now here, suppose if that fellow asked, what is this voltage V? What is this voltage V? V is equal to dash. I'm doing with nodal analysis. Or that fellow is asking, what is this current I1? Yes, this current I2 is nothing but, see, this current I2 is nothing but minus 5 amperes. The direction you see, I've taken current this direction, but actually 5 is upside. Therefore, simply I can write that I2 is equal to minus 5 amperes. I want to find I1 and voltage V. I'm writing nodal analysis. Nodal is nothing but KCL plus Ohm's law. I don't think this much depth questions will be asked to you, but still on safer side, let's understand. Yeah, I'm writing here. What is the current? See, according to KCL, what it is, sum of all the currents leaving is equal to sum of all the currents entering. What I assume is all the currents are leaving. Sir, people may think, yeah, Ashish, given answer as 5. Okay, let's find it. I don't know the answer. Randomly given some question. See, I'm assuming all currents are leaving. People may think, sir, why can't you assume all currents are entering? You can assume, no issues. For me, it is easy to assume that all currents are leaving. Yeah, current this way is leaving, this way it is leaving, but this current is coming, you see. So, okay, what is this current leaving current? V minus this voltage is V. This voltage is 0 by 2 plus V minus 10 by 2. Yes, V minus 10 by 2. These are the currents leaving, must be equal to entering current. Entering is 5, right? So V by 2 plus V by 2 is how much? Yeah, V minus 5 is equal to 5. So V is equal to 10 I am getting. Yes, V is equal to 10 I am getting. Yes, who given as Ashish? Yeah, you change the answer. Good. So V is equal to 10. Done. V is equal to 10 volts. That's all. Suppose if you want current I1, this is the current I1. Na? So I1 is equal to 10 minus this voltage is also 10 by 2. 10 minus 10 is 0. So answer is 0. The current I1 is 0. Right? So this is nodal analysis. Nodal means KCL plus Ohm's law. Same way, let's see one simple example for mesh analysis. Yes, mesh analysis. What is that? Mesh analysis is nothing but KVL plus Ohm's law. What is that? KVL plus Ohm's law. Simple example I'm going to take up here. Very simple example I'm going to take up here. So this is some voltage source. This is also some voltage source I'm taking. This is a reference. Let's take this one as 5 volts. This one as 2.5 volts. This one as 1 ohm. This one as 2 ohm. This one as 4 ohms. This way I'm taking. Right? See, any question if you have, you can happily type in the chat box. Okay, I'm here to reply your questions. Okay. Yeah. Here, how many loops are there? How many meshes are there? 2 meshes. See, loops are different from meshes. Loops are all possible closed paths. See, this is a closed path. This is a closed path. This is a total closed path. There are totally 3 loops. But meshes are, what is a mesh? What is a mesh? Mesh is a closed path in which there won't be further any closed path exists. Mesh is a closed path. Yes. So this is a closed path. This is also a closed path. In these, no further closed path exists. In these, no further closed path exists. Mesh is a closed path in which no further closed path exists. You know that this is plus, this is minus, this is plus, this is minus. I'll assume this current as I1, I'll assume this current as I2. Come on, I'm writing first loop, first mesh equation. What is that? Minus 5 plus I1. So this current is I1. Suppose if this current, if this current is I2, come on, this current is I2. Yes. Now tell me, here I1 is coming, this way I2 is coming. The net current will be I1 minus I2 in this one. I1 minus I2. So minus 5 plus 4 into I1 minus I2 is equal to 0. Minus 5 plus 4 into I1 minus I2 is equal to 0. So from that one, 4I1 minus 4I2 is equal to 5. This is equation 1. Right? That is equation 1. So this equation, if you write, you start from anywhere. So 2I2, I told you current entering is positive. So this is plus, this is minus. 2I2 plus 2.5. So here if upside I1 minus I2, downside it will be I2 minus I1. Downside it is I2 minus I1. So plus 4 into I2 minus I1 is equal to 0. This is equation 2. If you solve equation 1 and 2, you're going to get I1 and I2. I'm not going to solve it. I'm not going to solve it. Why? Because that much will not be asked for you in the examination. Just to tell you how we have to write KVL and KCL, nodal and mesh equations. Just I told you this one, right? Yeah, please. Let's go for next theorems. Or yeah, before I go for theorems, no, something I have to discuss, that is about sources. Okay, we have voltage sources and current sources, just their names and symbols and how they look. Okay, their characteristics, that's all. Okay, sources. See, sources, my heading is sources. Okay, so voltage sources, we have voltage sources, and we have current sources. We have what? Current sources. We have voltage sources and current sources. Voltage source look like this or looks like this. Yeah. Current source is going to look like this. Yeah. Only one symbol for current source. But these are ideal. Ideal means resistance is either 0 or infinity. Here one point I want to tell you. Ideal voltage source internal resistance is 0. Sir, how it is 0, why it is 0? It's a long story. If you are an electrical guy, I'll explain you with the concepts. Electrical concepts by taking generator as example, voltage drops, terminal voltage, blah blah, many things are there, but not required for you. Ideal voltage source, internal resistance is equal to 0. Internal, so this is a ideal, in fact, ideal. This is also ideal current source. Okay, ideal voltage source internal resistance is equal to 0. Here, ideal current source, yes, internal resistance is equal to infinity. Yeah, please do remember those points. Ideal voltage source internal resistance is equal to 0. Ideal current source internal resistance is infinity. Then practical voltage source, comma current source, comma practical current source. Okay, I'm not writing practical again, but it is a practical current source. How practical voltage source look? This is how practical voltage source looks. Means it is going to have some resistance in series. We call that one as in series with the voltage. It is source resistance or internal resistance. Current source, yes, that is going to have some resistance in parallel. It is going to have some resistance in parallel. Okay, so these are the symbols. This is a ideal. This is a practical voltage source. This is practical current source. Practical voltage source and practical current source. Right. The next is dependent sources. The previous sources what I discussed are the independent sources. In fact, all these are independent. Yes, sources independent. These are what? Independent sources. The next I'm going to discuss about dependent sources. What those are? dependent sources. Yes, you see, voltage source, dependent voltage source. Voltage source means its symbol will be, yes, dependent means diamond symbol, dependent, that's why diamond symbol. Okay, now if you have plus minus, that is voltage. If you have arrow, that is current source. Okay, if you have plus minus, that is voltage source. If you have arrow, that is current source. First of all, it is voltage source, but the name itself, it is saying that it is a dependent source. Suppose if I tried it as some k times of ix, you see, it is a voltage source. It is a voltage source, but depending on current, therefore current dependent voltage source, or it is also called as, this voltage source is controlled by current controlled voltage source. You can write completely in your notes. Okay, current dependent, yes. First of all, forget about everything, see the symbol plus minus, it is a voltage source. It is a voltage source, but this voltage value is going to depend upon current dependent voltage source, or it is also called as current controlled voltage source. Second one is, yes, observe here, even now also this is voltage source, now also this is voltage source. Observe here, this is voltage source. I'm writing it as kvx. It is what? Voltage dependent voltage source. Yes, it is a voltage source depending on voltage dependent voltage source, right? Sir, could you please recall the applicable properties of KCL and KVL? See, the same thing I discussed. Na? See, KVL, KCL should be applicable for any circuit. But there is one circuit called as non-planar circuit. I don't think that is required for you. For non-planar circuits, mesh analysis is not applicable, but nodal analysis is applicable. Okay, I told you KCL is Ohm's law plus nodal analysis is KCL plus Ohm's law, mesh analysis is KVL plus Ohm's law. See, Ashish, please be specific with your question. Sir, could you please recall the applicable properties? See, KVL, KCL are the laws. Okay, those should be applicable for any given circuit. If no circuit should fail this KVL and KCL, right? Next, let me take. So this is voltage dependent voltage source. Let me take about current sources also. Then we enter into some questions. Yeah, if you observe, this diamond symbol says dependent source, but this is a current source. Now, if I give like this, 2Vx, that is some constant k2, it may be 2 or 0.2 or it may be negative also, no issues. See, first of all, it is a current source, but it is depending on current dependent current source or current controlled current source, right? The next is, yeah, next is this one. This is 10, yeah, ix. First of all, it is a current source, but that is depending on current controlled current source or current dependent current source, right? So this is about different sources. Okay, next, answer this question, please. Answer this question. I explained you the concept, enough concept that is required to answer this question. Answer that question, please. Please, all of you, read the question and answer what he is saying. I'm expecting for your answer. I'm waiting, in fact. So I'm going to complete up to theorems today here. Yeah, one person answered it. Yeah, who's that answered? Ashish. Option is B. Okay. Any other? Any other? Come on, ma. Only Ashish. What about Vijay, Siddharth? Okay. Sudarshan, Tilak Raj, Rahul, Naresh. Lots of people try to answer. Yeah, let me answer it. Ideal constant current source is ideal. Ideal source means its internal resistance is zero. Sorry, infinite. Current source, na? Current source internal resistance will be infinite. Voltage source internal resistance will be infinite. Is connected in series with the ideal constant voltage source. The considering both together combination will act as option is B, constant current source. What that fellow says is, brother, there is a current source, there is a voltage source, both connected in series like this. This is equal to what? Current source only. Why sir and how sir it is current source? I will tell you. Why? Because see, if this current is I, this current is also I according to KCL, but we don't know this voltage. We don't know this voltage. Therefore, this can be represented with this one. Please do understand it or remember it. No issues. That is very easy question, right? Next, answer this one, please. Answer this one. Power is equal to, you can find these many ways, V into I, or I is nothing but V by R. No, if I is nothing but V by R means what is you are going to get? V square by R, or V is nothing but I into R into I, so that is equal to I square into R. So these many ways you can find the power. Please do it and let me know. I'm waiting. I'm waiting for your answer. Please do that, all of you. Answer, please. Yes, yes, I'm waiting for your answer. Yeah, Ashish given the answer as D. Yes, it is. D is correct. Remaining people, at least one or two. Yes, answer, please. So this is very simple. This is very simple. These two are in parallel, first of all. Make it as single. Yeah, whenever such kind of combinations you see, make it as single. 3 in parallel with 6. What is parallel combination? 3 in parallel with 6 is nothing but 3 into 6 by 3 plus 6. 3 plus 6 means 9. 9 3s, 3 2s, right? So this is 2 ohm. This is how much? 1 ohm, right? So the total is 3 ohms. Both are in series. It is 3 ohms. This is 3 volt. Now power is equal to, first of all, how much is the current? I is equal to 1 ampere. Therefore power is equal to, voltage is 3, current is 1 ampere. This is simply 3 watts. You can do in all the ways. In all 3 ways you are going to get the same answer. In all 3 ways you are going to get the same answer, please. Let's see. Yeah, here I think not required for you, that fellow not mentioned. Yeah, this question, voltage division. I taught you the voltage division today. Please do this voltage division, or I will do. Is asking V1. First of all, one thing we must fix here. Everyone can do, but there people will commit small mistake. Current will flow this way. Therefore, this is plus, this is minus. what he given and what it is exactly happening, actually happening, both are same. But here current is entering here, this should be plus, this should be minus, but that fellow taken minus here, means what that fellow is asking is opposite to what it is happening. Therefore v1 is equal to 20 into 2 by 3 plus 2. How much it is? 8 volts na? Yeah, 3 plus 2 5, 5 4 4 2. But v2 is equal to what it is happening actually plus minus, but what is asking opposite to that, minus. Total voltage 20 into 3 by 3 plus 2 is 5, so 5 4s minus 12 volts, it is minus 12 volts. Option is B. B for Bombay. Option is B, right? Yes. Then yeah, ideal voltage source should have zero internal resistance. Zero internal resistance, right? When three resistances with unequal values are connected in parallel, I told you, in series current will remain same, in parallel voltage will remain same. This shortcut I given already in the last class. In series voltage, in series current is same, voltage in parallel voltage is same. In series current is same, in parallel voltage is same. When three resistances with unequal values are connected in parallel voltage must be same. The current is same, no. The voltage drop across the resistance is same. Option is B. In parallel voltage remain same, right? In parallel voltage remain same, right? Ideal voltage source should have zero internal resistance. I think same question repeated again, repeated. The same it is repeated. Yeah. The dependent source in the figure is, this is the dependent source, diamond symbol I told you. But it is a current source, first of all. It is a current source. But the current source is depending on the current value. Therefore, current dependent current source or current controlled current source. Which option it is? Current controlled current source. Option is C. Option is C. Very good, Ashish. So, if any one of you from electrical background, no, not required for you to answer because simple questions I'm taking. Yeah. Kirchhoff's current law and voltage law apply for, I told, all kinds of resistive circuits only. No, there is no point like only. It is applicable for everything. So linear circuits only, option B is wrong. Non-linear circuits only, option C is wrong. Both linear and non-linear circuits, for both linear and non-linear circuits, this KVL, KCL are applicable. Yeah. Now, theorems. What is a theorem? See, big complex electrical circuits are there. It is very difficult to solve those circuits with general method. That's why we are going with some of the things called as the network theorems. What Thevenin's theorem says is, please do remember Thevenin's theorem. See, first of all, let me list out the theorems. List out the theorems, okay, and their applicability. Okay, see, we have these theorems. First one is Thevenin's theorem. Second one is Norton's. What is that? Norton's theorem. Superposition theorem. Superposition theorem. Fourth one is, I can say, maximum power transfer theorem. Maximum power, yes, transfer theorem. Last one is, I can say, Teligans theorem. There are few more theorems like reciprocity theorem and substitution theorem, compensation theorem. Those theorems are not important even for electrical guys also. I'm not expecting Rahul Singh, he messaged something, I'm unable to understand his message. Okay, Rahul Singh, you can type it again with the correct spelling. See, there are other theorems like reciprocity theorem, substitution theorem, compensation theorem, Millman's theorem. Okay, these theorems are not even important for electrical. I don't expect for you guys those theorems will be asked. See, first four theorems are applicable only for linear, yes, only for linear bilateral circuits. Linear bilateral circuits only. Yes, these theorems are applicable only for linear and bilateral circuits. Yeah, hi Mr. Rahul. I given my number. If you have any sort of questions, you can directly message me In the very beginning of the class, I given my number. Okay, take my number, feed it. Okay, yeah. Now this Tailor's theorem is applicable for both linear and nonlinear, both linear and nonlinear circuits. Means Tailor's theorem is applicable for all circuits, all kinds of circuits. Okay, what the Thevenin's theorem says is, sir, how many lectures are there for electrical classes? Hardly 5 lectures, 5 to 6 lectures. Okay, 6 lectures you can think of. 2 are already done, so 4 more lectures you can think of. Because for you guys, only definitions, units, these kind of questions only will be asked from electrical. Okay, they don't ask much things. Okay, fine. See, what Thevenin's theorem says is, suppose a very big network is there, very big complex circuit. All that circuit can be represented with simply what that fellow says. Thevenin's theorem states that any linear circuit containing several voltage sources and resistances can be simplified to a Thevenin circuit, Thevenin's equivalent circuit with a single voltage source and resistance connected in series with load. So what that fellow says is, any big network can be simplified this way, any big network. And this is where you are going to connect your load. So this is load. This resistance is called as Thevenin's resistance. This voltage is called as Thevenin's voltage. That's all about Thevenin's theorem. But Thevenin's theorem is applicable only for linear bilateral circuits only, right? Next, Norton's theorem. Exactly, it's a, I can say, counter statement, right? Any big circuit, complex circuit, can be represented with a current called Norton's current in parallel with resistance called as Norton's resistance, and that is equal to Thevenin's resistance. Here we are going to connect load. Right? Norton's resistance. Here we are going to connect load. Clear? Yes, that is Norton's theorem. Yeah. Reciprocity theorem not required for you. Superposition theorem. I forgot to tell you superposition theorem. Yeah, let me discuss that superposition theorem also. Then we'll wind it up. Okay. Superposition theorem. What superposition theorem says is, superposition theorem. What this theorem says is, see, in any linear bilateral circuit, the circuit must be linear and bilateral circuit. Suppose if there are 2 sources, let me take. 4 will become lengthy for us. Okay, this way I have 2 sources. What that fellow says is, suppose this is my output. I want current in this one. Current, see, this Ix I call. This is a current source. This is voltage source, Is and Vs. That Ix is going to depend on, Ix is a function of Is. Yes, Ix is a function of Vs also. Means Ix is going to depend upon Is. Ix is going to depend upon Vs also. Right? So what that fellow says is, if you want to find the current in this resistance and that current is Ix, you consider first Is, you remove Vs. Okay, what superposition theorem says is, response in any branch when all sources are acting or all sources are working is equal to sum of the individual responses when one source is acting. Means, see, response Ix in this resistance, first I'll find by using Is. I remove this Vs. Removing means, voltage removed means it should be short circuited. Okay, short circuited, find it. And later I'm going to find this Ix value with only Vs. I'm going to remove Is. Means Is should be open circuited, right? So that statement I'm not giving, just I'm dictating the statement. Please try to take it. The response in any linear bilateral network, the response in any branch is equal to sum of all the individual responses. What does it mean by total response and individual responses? Total response is the response by taking all sources at a time. means assume that all sources are there, you're finding it. But individual responses, summation of the individual response means consider one source for one time, consider one source for one time, consider one source for one time. That way you're going to get the responses. All those responses, if you add, then you're going to get response. That response is equal to that first response what we got when all sources are acting together, right? Yeah. So with this, I can say mostly I'm done with theorems, but in the next coming session, I want to discuss about maximum power transfer theorem. And after that, I'm going to start with the Faraday's laws. That fellow mentioned in the syllabus, Faraday's laws, and other things also, like the syllabus of power system is also there. Power generation concepts. Don't think that complete power system, power generation concepts, and electrical machinery concepts are also there. All those things I will be continuing in the subsequent classes. If you have any queries, as I'm giving my number, please you can contact me on this number. Okay, you can contact me on this number. Okay, fine. Yeah, synchronous machine. Yeah, synchronous machine, DC machine, all electrical machinery, transformer, all are electrical machinery. Fine. So mostly in 4 more classes I'm going to complete this one.